My lords, ladies and gentlemen, good evening. It's my absolute pleasure to be here tonight. Outside in coffee, I've already been asked once which Tom am I from the University of Bristol which does drones, because there are two of us. I'm the nuclear Tom, but then there is the volcano Tom, who is representing me at the University of Birmingham today, so that I could be here, in fact, which I thank him very much for. So we can get this to go on. So let me just jump to what Elaine was saying, actually just echo back what she was saying. Is drones represent for the UK and globally an absolutely huge financial opportunity. As Elaine's talked to, there's an opportunity for 42 billion in terms of the increase in UK gross domestic product. But at the same time, I think very importantly for the industries that I work in, there's an amazing opportunity for cost saving through the use of drone technology. And again, it's all about inspection and surveying. And from my perspective, what I'm trying to do through my research and with the research of my colleagues is to develop drone technologies such that they can become used in everyday life, ultimately. But we have to start somewhere. So we heard about drone usage in the filming industry. And of course, you think about lions on the savannah, nice open spaces, hardly any people, an ideal place to deploy drones. And equally, where I deploy my drones is on nuclear sites, which are no-fly zones for aircraft, and therefore I don't have the issue with worrying about bumping into other people's aircraft while I'm there. So in a way that's nice, because those are excluded areas or they're sparsely populated areas. But to consider drone usage every day beyond line of sight over cities and towns, that's a very different prospect. And we're a little way off that at the moment. So as I was nicely introduced, I'm a nuclear materials specialist first. So I do nuclear materials, I do sensors, and for me, drones and other types of robots are a platform for me to go and collect sensory data from places which matter. And invariably what I'm trying to do is capture information about where there is radioactive hazard and to quantify that hazard and work out, is that area safe enough for a human being to go into? And it's very much the same with the analogy with the oil and gas industry. I'm interested in developing drone technologies so that the drone can go into the dangerous location and I can stay at a safe distance and have a cup of tea while I see the data being recorded. That's much more complementary to my standard of life that I'd like to have, certainly. So Sellafield has been, for me, an absolutely fantastic opportunity to catalyse change in terms of drone technology and to challenge and try to change some of the culture in the nuclear sector to be more innovative in their thinking and approaches as well. A nuclear site like Sellafield has an awful lot of infrastructure on a very, very small area of land. It's high-risk infrastructure, you could say, with lots of very significant nuclear assets and nuclear materials, which could be regarded as being very, very dangerous. And a lot of the cost of the sort of £2 billion a year to run Sellafield site is around the people and the safety measures that need to be there to protect those people. And so what better place to cut your teeth than on a site like Sellafield, where you can demonstrate that drone technology can improve on safety and at the same time it can reduce costs. And so notoriously I was the first person with my team to ever fly a drone, a UAV, on a UK nuclear site. This was at Sellafield. And we conducted 15 flights over a 3-day period where we were given different parts of the site to try out the technology. And we demonstrated without any incidents whatsoever that we could not only record radiation data, we could fingerprint the radioactivity such that we could give a pretty good indication as to what materials lay in which buildings, which again was quite insightful for Sellafield and is potentially very useful technology. I should say that as with any first of a type demonstration of technology, this wasn't without some due level of stress for the team, because we had something like 15 members of the Civil Nuclear Constabulary with fully automatic weapons surrounding us at all times. Some of the guns pointed at the drone, some of the guns pointed at us in case we decided to do something crazy, which we duly didn't, obviously. But it showed that there was a level of anxiety and anticipation around that first-of-a-kind deployment that made it very, very serious for us, but thankfully it went without a hitch. And that's partly due to lots of practice and preparation, I should say. Now, in the nuclear sector, the potential value of developing robotic technologies is very, very significant, and it can help us achieve through the nuclear sector deal some of the cost savings that the industry has signed up to, but notionally sort of 20% reduction in cost up to sort of 2030. And part of the reason for that is because robots are beautifully repeatable in what they do. They can increase the efficiency, and for nuclear especially, it can remove the cost of having a person in a dangerous environment, and it can remove the person from that dangerous environment such that they don't get a dose of radiation. And in doing so, it makes things inherently safer. But because you have a robot that's very good at repeating things again and again, your productivity can go up, because a robot doesn't need to stick to an 8-hour shift. It doesn't need to sleep. It doesn't need to eat. It's not going to get cancer if it gets exposed to radiation. So there are lots of opportunities in robotics, and this is part of the drive funded by the EPSRC and Innovate UK to develop these technologies for extreme environments such as nuclear. Now, why UAVs and nuclear specifically? Well, we've heard some of the reasons, but the ones which are quite specific to nuclear is first of all, we can use them for lots of things. So you can do roof inspections, really simple thing, but roof inspections are quite important. And if you can send the drone up and it takes 20 minutes, you don't have to bear the cost of paying for a scaffolding to put up, which might take up to 3 months. The scaffolding might then stay up for a month. You need to hire some specially trained people who are qualified to work at height to come up, get on the scaffolding, get on top of the building, take photographs, get in really close. And they've done their job, they go away to write up, and then you've got another month or two for the scaffolding to be taken down. But all in all, the project takes something like 6 months, just for a roof inspection or a building inspection. And you juxtapose that with what you could do with a drone in a morning, you could get the same quality of survey for a fraction of the cost. And that's where I'm coming from when talking about the potential cost savings that we've got here. Drones in an emergency response context are incredibly dynamic in terms of being able to be rapidly deployed. If you have your kit in the back of a vehicle, it may be just a handful of minutes between parking that vehicle and having the drone in the air. It's so quick and so easy. And depending on what you want to measure in terms of the sensors, you have a variety of sensors available on the open market that you can choose the sensor for the application that you want and literally pop it on the bottom of the drone and off you go. So you can be recording thermal imaging, radiation data, laser scanning, lots of different types of sensor which give you different types of information. But invariably, many of these sensors can transfer data in real time such that the operator or the ground crew has an amazing situational awareness. And that's really very important. And of course, for emergency response applications, I'll show you some examples in a minute, the ability for drones to cover large areas quickly is very significant. It plays into this challenge of being able to send drones beyond line of sight, which is something you can't just do routinely, but in the event of a nuclear emergency, for example, would be perfectly acceptable to stretch or even break what would be the standard rules in order to be able to give you mission-critical information to potentially save lives. So, brilliant technology, and autonomous flying is something, when I started working with drones, which was just after Fukushima in 2011, the drone technology as it was then was rather crude. You wouldn't trust your drone to fly autonomously because it might wander off into a cliff face, for example, because GPS wasn't particularly accurate. You wouldn't particularly trust them on landing either, so you might, in the early days, do crazy things like catch landings where you catch the legs and then turn off the power. But now the repeatability, the reliability, the robustness, and the ability to use autonomous flight is absolutely fabulous, such that the risk of a drone going down during flight is very much reduced than it ever was before, and improving every day. Now, for radiological inspection, 3 key things are very important. One is repeatability. If you're going to use drones for emergency response, you need your drone team to get regular practice. And what better way than to do routine inspections as the way of practicing to deploy and use your kit? And whereas if you had someone on the ground walking around a site to do a survey and you asked them to repeat the survey 2 weeks later, invariably they're not going to walk exactly the same path lines that they walked the first time. Whereas with a drone, and I've done this in Japan many times on nuclear waste dump sites, you just reload the mission you did last time and you press the go button and you'll get within 1 or 2% positional error, exactly the same survey that you got last time. And that allows you to record survey data where you can compare from one time to another. So you can compare apples with apples as opposed to apples with pears. And the same argument about removing humans in terms of them performing the survey, for radiation, a human being is a bag of water that's walking around. And water is really good at blocking radiation. So if you give that bag of water a radiation detector, and there are different radiation sources around, that bag of water is going to block some of the radiation which would otherwise reach the detector and cause you to underread what the true radiation is across that area of sight that you're surveying. So a drone, which is invariably carbon fibre and some aluminium and some other types of composite, is very poor at blocking radiation. So it's much better in terms of giving a much better sensitivity, and it removes human error through having that repeatability as well. And as proven with tests that we've done in the UK, but also in the US as well, these drones have an amazing proven sensitivity, which is comparable to an on-the-ground survey, whether you're using a human or a robot. But it gives you that capability to do that survey without the human physically having to enter that site of hazardous radiation. So I'll use Chernobyl as the example. If anyone's watched the Sky Atlantic series, it's a pretty good representation of what happened. Very exciting. World's worst nuclear disaster. And back in 1986, they didn't have drone technology, so what they had was helicopters. They didn't have a means of real-time measurement and mapping, so they would literally fly from location to location and make point measurements and take ground samples, and then just interpolate the data to form a map which spatially is very, very crude in terms of its spatial resolution. So today we can do it differently. This is where I hope it will now play. So the Red Forest is the most radioactively contaminated piece of land in the world. We now know from our drone measurements that if you went into the centre of the Red Forest for even a period of hours, you might get a dose of radiation which could be lethal for you. Still, after 33 years at the event. So the Red Forest today, if you fly over it, doesn't look particularly healthy. That's partly the radiation, partly because it had a forest fire a couple of years ago and it hasn't recovered particularly well. And so the way to do this, if you can't physically enter that hazardous space, is to send a couple of different drones. So first of all, we send a fixed-wing drone, which we can hand launch very, very quickly. That's got a twin set of radiation detectors in it, which map at about 10 hertz rate. The radioactivity is a function of position, using lasers to make sure that it knows its height above the ground. And we send it off on a couple of racetracks, flying up to about 60 kilometres in one flight, and bring it back to where we are by using a parachute, because there's no landing strips in Chernobyl, funnily enough. And when we find something of interest, a hotspot, we can then send in the multi-rotor drones. And again, same principle. These can fly beyond line of sight, but directly over the hazardous area they can hover, or they can move very, very slowly, and they can fly much lower than a fixed wing. And that gives us an incredible spatial resolution, comparable to being able to do it on the ground. And very much thanks to EPSRC and as part of the National Centre for Nuclear Robotics. This was the first of a kind demonstration anywhere in the world of using a UAV flying beyond line of sight to cover a very large area of land. It's 15 square kilometres to map the on-the-ground radioactivity. It shows that we have the capability today that if we had a nuclear emergency on a site in the UK or elsewhere in the world, we would be able to use this technology to very, very quickly map the extent of the radioactivity and understand where it had gone and how much had come out. Now, that's incredibly important. And the reason we developed this technology is because after Fukushima, we wondered why the Japanese didn't have that technology immediately available. So we worked with the Japanese, specifically the University of Kyoto, to develop that technology. We can use it today in Japan, Ukraine, UK, in fact anywhere in the world. It's really nicely portable. So we're using a number of different types of drone. We're using them collaboratively. We use the fixed wing to fly large areas, and if we find something of interest, we use the multi-rotor to go in, and just in a relatively smaller area, we do much higher resolution. And that's because, principally, the multi-rotors can't fly as fast, and they can't fly as long, and so we have to use the right tool for the right part of the job, and that's why we use them collaboratively. In fact, we typically use different sizes of drones. The first thing we do, if we go to a site where we don't know what the hazard is, we don't know what the highest object is, we will take a very small reconnaissance drone, range of about 5.2 kilometres, and we will check out what the highest object in the survey area is. And once we know that, if we're going to do a fixed-wing UAV survey, we'll whack 20 metres on top of that, and that will be our safe flight deck for doing our surveys so that we're not going to hit anything. So it's very, very useful to have different types and different sizes of drone, and obviously the smaller drones pose a much smaller risk to infrastructure than the larger ones. And that's a really important thing when thinking about regulation, because a drone that weighs 1/4 kilogram, if it falls on your head, it's probably going to give you a bump. It's not going to kill you, but a 25 kilogram drone that falls on your head from 100 metres is certainly going to do you a lot more damage. And whilst neither weight class potentially could damage significantly a building, a 100 kilogram drone is definitely going to damage your roof if it lands on it. So there needs to be an appropriate set of different classes, I would argue, for drones that represents the different risks that they potentially pose. And of course, if you're going to deliver things, like parcels, you're going to need bigger drones to be able to pick them up in the first place, which means the risk is slightly higher. So, as we've talked about, there has got to be this convergence between the technology, which is developing very nicely, societal acceptance that people don't want to be overlooked by drones, but they do want the drones to be used to save people's lives, and the evolution of the regulation. These things have to come together, and we need to have evenings like this where we can discuss these things and look at the interplay between them. Certainly, I participated in the Drones for Good competition a few years ago in the UAE. They're fascinated by drones. The Crown Prince, you can see him in the vehicle there. And his viewpoint is that they should have aerial taxis flying around Dubai, delivering people from A to B. That technology is at working prototype stage. We probably won't see it in the UK for some time. But it's the same basic technology for drones. It's just a bigger one, heavier weight class. So, what's really important for many of these applications is flying beyond line of sight, and we've heard from Elaine how important that is. If you cannot, as the pilot, see the drone well enough to properly control it and understand where it is, then it's beyond your line of sight. And you shouldn't be going that far in the first place. So if you are going to fly beyond line of sight, you have to find alternative methods which allow you to have the same degree of control as if you were a pilot, a tiny little pilot sat inside that drone, so that you've got an awareness of potential objects around you that you could collide into, and duly you avoid them, of course. So, BIVLOS that we call it, which is a horrible sort of acronym, you need to have a capability for detecting and avoiding objects. Now, some of the off-the-shelf drone systems that you can buy now will naturally have that built in. It's usually based on cameras or acoustic sensors which are distributed around and underneath the drone so that they can understand where they are relative to the ground surface and any objects, and they have built-in software to automatically avoid objects which are in close proximity. It's very, very useful. You also often, if you're going beyond line of sight flying, you have to work in a block of airspace which is essentially cordoned off. Nobody else is flying anything else inside that airspace. Now, that wouldn't be commensurate with lots of drones trying to deliver packages all over a city. We're not there yet. We're still taking these early baby steps to be able to deploy this technology. And you also have to provide clear evidence, and we had to do this with Chernobyl, in fact, that there is no aviation threat, and that any people that are on the ground within your cordoned off area are typically aware that the drone is there, and they're aware of its location whilst it's flying. For flying around Chernobyl, because we were flying very, very close to the reactor building, the new safe confinement structure, we had to do calculations for the different drones of the kinetic energy that we could have flying at full speed if we impacted the structure, so that they could work out if there was a chance that we could damage the reactor confinement building. Obviously, the drones we were using were quite small, so there was no risk, but still we had to do that. And simple things like whenever we were taking off, we had to phone in to security, we had to phone into the regulator and let them know we were taking off, and as soon as we'd landed, we had to phone in again and let them know we'd finished. We had to do that every single flight. We had to have 1 or 2 different regulators observing us at any one time. So still quite a lot of oversight and a lot of regulation, even in an area which is completely excluded from flying usually. So we have had a breakthrough recently, the first beyond line of sight demonstration done up in Cumbria by Blue Bear, who works with the University of Bristol, mid-October. And whilst technically it was beyond line of sight. There was still a safety pilot that was in line of sight in case anything went wrong. So essentially a safety net, if you like, in terms of being able to take back control from the aircraft. Now, in the UK, we're very well regulated. In other countries, sometimes there's no regulation at all, which for academics can be quite fun, because then we can do what we want. No, we can't really. So the University of Bristol with Volcano Tom, who is the other Tom, done an awful lot of flying over volcanoes during eruptions, but in different countries, so Papua New Guinea, Chile, also in Italy as well. The reason I like volcanoes is because they're a perfect analogue for a nuclear reactor that's just blown its top. And we've got a plume with some radioactive gas and some solids, and we can use the drones to fly into the plume to take samples or to fly around the plume, taking photographs and recreating a three-dimensional structure for the size of the plume. And then you can start to estimate how much radioactive material is inside. Now, two examples here, one on Ascension Island, which is in the middle of the Atlantic, so not too many people there, maybe a few submarines, and on Montserrat. So these are both UK overseas territories. On Ascension Island, we were working in segregated airspace, flying up to about 3 kilometres to sample atmospheric gases at different heights. And in Montserrat, I think it's more complicated. We were sharing airspace with more traditional air traffic, but there was a really close connection and coordination such that there was no chance the aircraft would come into any sort of proximity with each other. So if we are going to take this leap, which I think is essential to realise the value of drones by enabling beyond visual line of sight flying, we need to do a number of things. And please bear in mind, this is my view, and other Tom shares this view as well. Is the first thing is you need to, on board, have a proven detect and avoidance system. Okay? And that needs to be approved specifically for the airspace type and for the airframe as well. So there's no point having a really good avoidance system, but it's too heavy for the drone to carry. Then it won't take off. You also very likely need to have electronic conspicuity, but essentially some kind of transponder device on the drone which is sending out messages saying, I'm here, I'm here, I'm here, so that systems on the ground can understand where those drones are at any one time. And if you've got that capability, or jump straight to D, then you can have essentially an aerial traffic management system. Now that will only work if all of the drones have transponders, and I'm sure in the questions we'll talk about what the bad guys can do, and the bad guys very likely aren't going to bother with transponders. That would spoil the party, I'm sure. The last thing is about the expectation for the drone system to have very good communications with the people who are in charge of it, who are either operating it or monitoring the UAV. And that's where, for example, you could use standard directional radio telemetry, so standard radio control. But I think more exciting that you can use 4G or 5G. And this is where development through the industrial strategy for 5G-enabled networks in all the towns and cities across the country, once we've got 5G, that actually helps to unlock us using beyond line of sight flying across towns and cities. You wouldn't do that in the wilds of Scotland, because you probably won't have 5G there. But certainly for complex flying situations, you get very high bandwidth, essentially, that would unlock that capability. But of course, if you've got lots of money, you can do this already to some extent with satellite uplinks, but it's relatively costly. So the last thing I'll say, because I've got two not so small children anymore, who grew up with drones on the kitchen table, and so they're familiar with all of my drone technology and all the changes that have happened. But you'll see this Christmas, I saw it last Christmas, that kids are given drones as presents. Small ones, yes. And I think there's an incredible value, because I do a lot of outreach work with schools, in that drones, and I've seen it, are an incredible way to unlock a child's interest in engineering and science. And learning everything about gravity for a drone, that's an easy one, but understanding different types of sensors that might go on the drone, how they understand their position, so understanding global positioning. It's a really great way of enthusing children about science and engineering. And societally, I think we really need to make sure that we're preserving any opportunity to encourage children to become scientists and engineers, because these guys will be the ones who are developing the solutions to some of the challenges we have around climate change, water shortages, enough food for generations to come. So we need to make sure, if we're going to evolve the regulations around drones, that we're not going to be too draconian. So we're not going to take drones away from those children. We can still have a capacity that allows children to have access to this technology, so it unlocks their minds as to the benefits of other science and engineering technologies. So in summary, I will conclude that I certainly think that drones offer a very significant opportunity for the UK. We're a leader internationally so far, and I would argue that we should continue to push to be at the forefront of technology development. We do need to evolve regulation and legislation, but we need to do it sensibly. We need to have due consideration for the good and the bad, and I'm sure we'll talk about that this evening. And I would just say, don't forget the benefits it has through education to have access to robot technologies which can really enthuse young minds. So with that, I think I'm done. Thank you very much.